Alright, so let's continue looking at these review problems from Skill Packet 3. We just did 5, 6, and 7. So now we have a whole series of problems that's asking us for the domain. Now, when we have an equation for the domain, we always start in the same way. The domain is a set of all real numbers, excluding any values that cause division by 0, and excluding any values that would cause us to take the square root of a negative number. Alright, so I paused the video and just typed that out for you real quick because this is what I think and what I say every time that I'm finding the domain from an equation. Alright, so when I look more specifically at this equation, the first my default answer is always the set of all real numbers. But I have to take a look at the equation. Do I have any variables in a denominator? Well, in this case, I don't. So I don't have to worry about any values of x that would cause division by 0. In the second part to consider, excluding any values that result in taking the even root or, such as a square root of a negative number. So I need to focus my attention on this expression that's underneath the radical, this 6 minus 2x. See, that represents a real number, depending on the value of x. Well, we need that to be 0 or positive. We cannot allow that number to be negative because then we would be taking the square root of a negative number, and we're working with these functions with real valued functions. We're not working with a set of complex numbers. So this 6 minus 2x, we need it to be 0 or positive. So we need to solve this inequality for x. I'm going to add 2x to both sides. I'm going to divide both sides of the equality by a positive 2. And it's logically equivalent if 3 is greater than or equal to x to say that x is less than or equal to 3. I like having the variables on the left. Notice that the inequality pointed towards the x, towards a smaller value. It's still pointing towards a smaller value. If I think of all of these x's on a number line, I've got the number 3 and over here 4, 2, and so forth. That goes on. Well, 3 is acceptable because let's evaluate this function at 3. If we go f evaluated at 3, 6 minus 2 times 3. That's 6 minus 6. And that's 0, and the square root of 0 is 0, and 0 plus 4 is 4. So I know that this graph passes through the point 3 comma 4, that when x is 3, y is 4, that this is my relation, and I know that that relation is a function, so 3 is only related to 4. Alright, now what if I tried to evaluate this function at some number that is larger than 3, something like 4? Well, when I go underneath the radical here, 6 minus 2 times 4, that's 6 minus 8, and that's a negative 2. And within the set of real numbers, I can't determine a real number in order to add it to 4 to get an output. So we say that this is undefined, that I can't add these two values together because this first one isn't a real number. So it's undefined. I need every number in the domain. If 4 is in the domain, I need it to be defined to be related to some y value. 3 was defined to be related to 4 through this equation. Well, 4 here in the domain can't be in the domain. What about a number that's less than or equal to 3? What about all of these numbers? Well, if you plug in a number 2 or anything like that, this subtraction problem is going to be positive. It's 0 when you plug in 3. It's going to be a positive number for values less than 3. So that's my domain. Now I need to describe that domain using interval notation. My sketch here of the number line often helps me to write it in interval notation. I usually just use a capital D. Capital letters are often used for sets. I use a little subscript f to indicate the domain of f, and then equals, and then this, since the arrow is shaded, I start with negative infinity as the smallest value. I can't write a bracket there because it's truly not an endpoint, it's not a number, and then that goes all the way up to 3, and since I'm including 3, that when we inputted 3 we got an output of 4, we have a square bracket there. So there's our answer for number 7. The domain is a set of real numbers that are less than or equal to 3. Hope that helps, and I'll do these on separate videos.